Okay, so I'm looking at this question in that nonlinear systems open math assignment, and um, what's happening here is they're asking us to graph. Really, we can do this graphically, and I almost advise you to do this graphically. I've got a circle with a center 0, 0, and that's the radius squared, right? Then we get this function here, or the function, this relationship here. They're asking me what conic section it makes. Well, in the forum, I linked to this page. Well, actually, it's the page before this. It's about conics. And it just so happens when we start looking at graphs of conics, and really, you don't have to do any work with this. I mean, we don't need to understand what conic sections look like in order to do calculus. It's kind of old school stuff. There's just this one my open math question is asking us to do that. So what happens when you have these curves that look like this? It's a hyperbola, and I won't show you in this video, but I encourage you to go out and look. Find some pictures of when you take a cone and you slice it. Where do you get the circles from? Where do you get the hyperbolas from? Where do you get the ellipses from? I mean, it's kind of cool to see. Just be aware they exist, and don't sweat the stuff about it. And so I've got two kinds of hyperbolas, and one is parallel to the x-axis, and one's parallel to the y-axis, and there's all kinds of ways to analyze that by hand. I encourage you not to do that. So what I did is I went out to Desmos and I graphed. Well, let's see. Here's the one that I was given in that question, and they asked me what kind of conic section I'm seeing. Well, I'm seeing a hyperbola because it's coming in, swinging back off. Then they're asking me what's the center, and well, how do you find the center? Well, do you remember back when we talked about if we take let's see, let's just deal with that. Let's deal with the different conic sections we have been dealing with. What if we do a parabola? Give me a second here. Oops. Actually, let me do this. Let me put H here. So I've got that slider for H. So do you remember when we have a value inside the argument of a parenthesis, we can shift it left and right by so that's the left right shift for the x. And then the y is the k part where it shifts it up and down. Well, it doesn't matter what relationship we're dealing with; it still holds. That same thing still holds. So if we look at here, let me put these back to 0. Oops. I'll get there eventually here. There we go. Well, I was almost there. Let's graph this hyperbola that I set up quickly. So how do I figure out the center? Well, right now I'm seeing the center is 0, and you see what value k is? And this is parallel to the y-axis, the vertically aligned hyperbola. If we start adding a number to making the k be a number, do you see how that's shifting up? In this case, I'm shifting it up 2. Now the center of that parabola, that hyperbola is 0, 2. Well, it's the line y equals 2, and it's the coordinates are 0, 2. So if I come back up here, and then, well, actually, let me do this. Let's see, and I want that to stay 0. If I make this 3, see how this is y minus 3, and that's the center of that hyperbola. We can do, if it lets me do 4, let's see, let me see if I can do 4. See how the center of that parabola is the line y equals 4, so at 0, 4 is the center. So now let's look at that equation they gave us, or at that relationship they gave us, and I see the k is 14. So that tells me the center of that that parabola, or that hyperbola, is going to be 14, 0, 14. And we can kind of see that. If I have a graph y equals 14, we can probably see the center line. So to get the center of these hyperbolas, you just got to look at the, especially with this question, you'll just look at the number they have there, and that's the center. So let's go back and answer some questions here on this MyOpen Math assignment. So I see a hyperbola. I see the center at 0, 14. Then I'm going to figure out where, if this is going to intersect the surface of the Earth based on the scenario. So I'm going to go back to my Desmos graph, and I already put that equation of the Earth in there. Let's get rid of that. And I see it does impact the Earth right there. So that's going to be the solution to get this MyOpen Math question correct. So what is it? Negative, let me shrink this up a little bit maybe. So negative 5.11 and 3.187. Let's see if MyOpen Math likes all this. And it does. All right, so that's how you'd solve this question. You can certainly do it analytically, except it's starting to get pretty messy, so I wouldn't advise you to do this. This problem actually isn't doing what I wanted it to do, but it'll get it right. If you get it wrong, let me know and I can adjust your points.